So, the sinking fund. What the sinking fund is when we kind of want to go in reverse. We know a target amount we want to get to. We want to figure out how much do we need to save each period given a certain amount of interest and compounding that will be added to it to get to a total in the end. So in other words here, the ordinary annuity formula solved for the R, the regular deposit. So one may determine the regular deposit amount needed to reach a desired future value with the known compound interest included. So in other words, it's just the ordinary annuity formula solved for R. So it looks like this. Let me go ahead and grab that. It's R equals V, the final amount we're looking for, times the interest rate as a decimal, divided by the number of times compounded per year, all divided by 1 plus the number of times compounded per year, divided by, the rate divided by compounded number of year times, to the n total number of times compounded over the life of the sinking fund, minus 1. So this is really just the same thing reversed, right? We've just solved for R now. So let's take that same situation that we had before. Let's figure out if it would tell us to get to the same amount of payment, our $25 payment that we had started with. So if you recall, we'd come up with $16,675.65. So we had a 4.8% interest rate, so we're going to use 0.048. Divided by, it was weekly, so there were 52 weeks in a year. All of that divided by 1 plus our interest rate, 0.048, divided by the compounding periods, 52. And again, all of that to the number of times totally compounded. So we had 520 times minus 1. So how is this going to look in our calculator? So we're going to have, let's see, the numerator and denominator are about the same. So let's go ahead and say a numerator divided by a denominator, right? And so then let's talk about the numerator. First, we're going to go ahead and do the parentheses. So 0.048 divided by 52. And then we're going to multiply that by the $16,675.65. Make sure we remember that decimal. Down here in the denominator, let's see, we have to do the parentheses first again, right? So let's go ahead and start there. So in the parentheses, we're going to do the division first. So 0.048 divided by 52 is in parentheses. Then we can go ahead and add the 1 to it. So let's add 1. Put all that in parentheses. Then that is going to get raised to the 520th power. 520th power. Let's see, all of that we have to subtract a 1 from, don't we? So let's get a last color in here. So right here, here, minus 1. So that's what we're going to go ahead and put in our calculator. We go ahead and throw that on in there. Right? Like I did it that fast. And we end up with 24 I love this, 99998 653 ... right? And so since we're trying to get to a target, we automatically, no matter what, have to round up so that we get to or surpass the target, right? So our 9 cents goes up to 10 cents. So we're going to, of course, carry a 1. That 9 is going to go to 10. You're going to carry a 1. And there it is. There's our $25 magic number payment that we got right back to. So there's your sinking fund, folks. It's just figuring out what the payment is to get to that target. But it takes into account the interest you would earn along the way, which is the really cool part about it. Example would be like if you needed to buy a big piece of heavy machinery and you planned for it ahead of time, like a smart business person would. You know, in 5 years from now, I'm going to need a $100,000 piece of equipment. Well, you can use that 5 years to earn interest on that large amount of money to help you get to that target. Why not, right? That's the whole point. So there's your sinking fund, folks. I hope that helps you out, and I'll see you in class. Bye.